Okay, I'm going to teach you how to do part A. So when we do part A, so everyone, are you with me?
Yes, miss.
Yes, okay. So how to do part A? We have to look. You see, what is this power? It's negative, but this power is positive, correct? So what we need to do, we know this concept. A to the power of n times a to the power of negative n, what do we get? A to the power of 0, which is 1. You can do it like that. If you don't want, you also can do it this way. A to the power n divided by a to the power n, I get also 1. So either way, it can work. Are you clear? Hello, student? So that is the concept that you must have in mind. So for part A, what I do is I have my fx. So I can do it this way. Every term in the fraction, if I multiply with I can do it like that. So that is correct in the sense that the top you time by e to the power negative 0.3, the bottom you also do so. Are you clear? So you have to show this step. That is called show. Okay, then plus 20 times e to the power negative 0.3 x. And you know that this one become 1. Here is 1. So bear in mind, this is 1 from this concept. Okay, so it's 200 divided by, here will be 1. It will be plus 20 e to the power negative 0.3x. So this step is the one that will give you mark. Clear? Okay. Any question? No, Okay, then we go to the next part. Okay, what rule are we going to use? Can anyone give me a suggestion of what rule to use to solve for part B? Yes, chain rule. Thank you. So I use chain rule because the top is a number. So I bring it up. Power negative 1. Right? So now I start to use chain rule. Bring down the power. Copy down the whole thing. Power take away 1. Time by the derivative of this one. That is here. So if you see any exponential term, what you do? You also follow. Copy down the whole thing. Then you multiply by the derivative of the power. That is negative 0.3. Then you take out your calculator and multiply all this number. So you will get 1,200. Am I right? E to the power negative 0.3x divided by, okay, since this is a negative, I straight away write divided by. Okay, and you know that to get the stationary point of any given function, this happens when f prime x is equal to 0. So you know this already. So you don't have to write. What you can do is when you do your working, you can just write there 1200 e to the power negative 0.3 x equal to 0. This is a fraction. You know the true fact already. So you see, you must remember the way you present the answer and the way I explain, we do it in a different way. So when I explain, I will tell you, oh, this whole thing equal to the 0, then you bring over, you multiply something by 0, you get 0. So in the exam, you can straight away write down there. Then you can write down no solution. Then you can straight away make a conclusion. Therefore, y equal to fx doesn't have what? Stationary point. Right? Hello? So this function, can a function go without stationary point? The answer is a yes. Okay, then I ask you to sketch the graph of y equal to fx and y equal to f prime x. Hence, find the coordinate of the inflection point. So everyone, do you get the graph? Okay, can anyone in above class, someone please send to the WhatsApp the shape of the graph that you have transferred onto the paper. The graph that you have. Okay, group 1, Siti Hajar, can you please send your graph to the group? I
haven't sketched the graph, miss.
Oh, you haven't sketched the graph? Okay, Johan have sketched it on the graphic calculator. Or Johan put it on the graphic calculator. Group 2?
Just to be sure, I had to type in different multiple numbers in the window just to get a clear picture.
Yeah, I told you already. Okay, so everyone, for part C, right? I told you already, you can try with your window, x minimum equal to negative 10 and x maximum. So in the exam, you have to try by yourself. This one I try already. You put 40 or 30 is also fine. Okay, put 40. Okay, then after that, you have your y1, right? You type in like that. Your y1, you type in like that. Don't type in the complicated one. Because they are the same thing. Okay, then your y2 should, you don't have to type AD. Everyone y2 should be this AD. Am I right? Okay, then after this is your window. Okay, this is the first step that you do. This is the second step. Then the third step, you go to zoom. You select zoom fit. Okay. You will take some time. So this is your y equal to fx, right? And this one will be your y equal to f prime x. So you have to find the coordinates of this point. Okay, can someone give me the coordinates for this point? Okay, I give you time to do. Ashwindaran, did you get the graph? Hello? Okay, for this question, can anyone tell me why? Why Mr. asked you to sketch even this graph? And I use the word hence. Find the coordinates of inflection point of y equal to fx. So how are you going to use that to answer the part C, the hence? Okay, may I know? Okay, Thaddeus, is this the answer for part C, hence?
No,
No, why not?
because the y isn't 15.
Yeah, because this is not y equal to. So you are looking for this point.
Yeah.
You are looking for this one, correct?
Yes.
So you have to put into your fx to get the value of fx, am I right? So can you all please do so? So I only know the x coordinate. I don't know what is the y coordinate of fx. That is the reason why I asked you to sketch the graph of y equal to f prime x. Because you know the true fact about what? The x coordinate of the stationary point of y equal to f prime x is the x coordinate, or talk about x coordinate of the inflection point of y equal to fx. So this is the relationship that you and I must know. Very important. So that's why I asked you to sketch both graph and say hence. So you can use your graphic calculator to help you. You say when x equal to 9.99, your y1, 9.99, you should know how to get it from your graphic calculator, correct? Okay. May I know what is the answer? Okay. May I know what is the answer? Adele, Ayman?
I got 100.06.
Okay, so is the exact one should be 100. Afterward, I tell you why, okay? So it's 100. So therefore, the coordinates, thank you, the coordinates of inflection point, I will say this is a non-horizontal, right? You should know. Non-horizontal inflection point of y equal to fx is 9.99, 100. Okay, Can I ask further? Can someone tell me that? Describe the changes of y equal to fx at this point. Describe the changes of fx at this point. Gladys?
At this point, the y equals to fx is increasing at the maximum rate.
Yes, at the maximum rate. And you will usually say at the fastest rate, at the greatest rate. So up to you, whichever word you want to use. All right? Hello? So this is another interpretation that you must have. At x equal to 9.99, y equal to fx is increasing with the maximum rate. No problem. You can use this word. Or you can use another one is increasing with the fastest rate. Or if you don't want, you can say greatest rate. Up to you. Okay? Okay, I would like to ask why I use the word increasing. Why I use the word increasing? Cindy? Why we use the word increasing and not decreasing? Cindy? Try why we use increasing and not decreasing. Look at the fx graph.
Because the x equals to 9.99.
I'm saying why here I use increasing and not decreasing. Based on the graph, you look at the graph, why I use increasing and not decreasing. When we talk about inflection, we can have two changes, correct? One is increasing with the greatest rate. The other one is decreasing with the greatest rate. Can also. That's why, do you know why I try not to use this word? When you say maximum rate, but because it's decreasing, correct? It's a negative rate. So you cannot say maximum decreasing with the maximum rate, because the rate is the lowest point. So it's better to say fastest or greatest rate. Hello, Cindy. May I know why we use the word increasing?
Because it is positive.
Yeah, no, it's not because it is positive. If you look, I'm asking you to look at the fx graph, not the f prime x. Yeah, I know you are looking at the f prime x. So what can you see? I look at the graph, fx I know already. I should use increasing. Try.
Concave downwards.
Okay, when you want to say a function is increasing or decreasing, right? We look at the graph of that function. We see whether the graph is going up or going down. We don't look at the shape. You see or not? Because fx is going up. You get me? So when we want to decide what word to use and we refer to the graph, we have to know what we have to look for, right? I use increasing is because y equal to fx graph is going up. You see, going up, I draw the arrow here, going up. Got it? Okay, done. I just want to ask you, without part D, drawing the sign diagram, can you describe the changes of fx from here? Can you? Can you describe the changes of fx? So I draw another graph. I'm drawing the graph of fx. Huh? Okay, my fx is equal to 200 over, use black better, 1 plus 20 e to the power negative 0.3x. Okay, stay focused in class. Huh? For max, correct, I cannot keep checking text or whatsoever. I don't know whether is your, okay, so now you look at here. So still, if you look at the graph, because it's an exponential, so the domain is x. X is a member of real number. Any number can do. So I want to study what happened if x goes this direction, positive infinity. And I want to know what happened when x go negative infinity. So still remember, I teach you how to do as x approaches infinity. So the terms that involve x is this term, correct? So you ask yourself, what happened to e to the power of negative 0.3x? What happened? Hello? Approaches what? Approaches 0. Okay, thank you. So my 20 times e to the power negative 0.3x will approach 0 also, correct? Because this one approaches 0. So therefore, so you have a lot of, you trace from one to another. So therefore, 1 plus 20 e to the power negative 0.3x will approach. So remember, this is 0. Yeah, so it will approach 1. So therefore, my fx equal to 200 divided by 1 plus 20 e to the power negative 0.3x will approach what? This one approach 1. 200 divided by 1 will become 200. And the rest of the value will be less than 200. So this is our upper limit. So this is your upper limit. So we always write here from below. So it means it tells us that my fx will not go beyond 200. So that's why I call that the upper limit. So I straight away know from here my fx is less than 200. So this will become my range. So now how to get my lower part of the range? So I study this direction. As x approaches negative infinity. So what happened to e to the power negative 0.3x? What will happen to that? Yeah. Anyone? Christopher, what will happen to that?
Or is it go to 0.
Okay, let's have a look at this. E to the power negative 0.3 times negative infinity. Negative times negative, you got positive, correct? So what do you think? E to the power infinity, it will approach, Christopher?
Infinity.
Yeah, infinity. So if that go to infinity, we actually, this one you can straight away say your fx is 200 divided by 1 plus 20 e to the power negative 0.3 x. So the bottom here is infinity. 200 divided by infinity, it will become very, very small. It will approach 0. So your lower limit for your fx will be 0. Are you clear? So you have two horizontal asymptotes. That is y equal to 200 and y equal to 0. That is your x-axis. Are you okay? So that is the part that you need to study. That's why I say all these limits are very important. Okay, so can I settle the part D? Can I settle part D? Okay, I
Miss,
think yes.
if the question asks us to like sketch the graph, do we have to find the asymptote also?
Yeah, you have to.
Oh, okay.
Actually, what you can do is you can go second graph. You look at the table, you will know whether there is a horizontal or vertical asymptote. You go to second trace, there is the table of values of table, then you can see. Try, go and study about it first. Hello? So I'm going to
Okay.
settle your part D. So your part D, your fx sine diagram, there is no x-intercept, correct? There is a y-intercept, but there is no x-intercept, always positive. Okay, your f prime x sine diagram is also because fx is always going up, so it's also always positive. But your f double prime x, there is an inflection point at 9.99, correct? So I have to mark here 9.99. And here is concave upward, so it's positive, and here is negative. So when I use this to describe, and when you base on the graph, how are you going to describe? You say for x, so this is a crucial point, less than 9.99. Y equal to fx is increasing with, okay, I'm going to ask someone to tell me increasing with what rate? How's
Increasing.
Increasing rate, because the graph become steeper. So there's no stationary point, so I don't have to stop at stationary point. So that is how we describe. Then at x equal to 9.99. Okay, can someone help me to explain? Kiko Faraki.
Is it also f prime x is increasing with
Oh,
increment?
I'm talking about fx, young man.
Oh, what are you asking?
I'm asking you to describe the changes of y equal to fx. That is your question for part D, am I right?
Yeah.
Mm.
Uh,
At x equal to 9.99, y equal to fx is? You are not in the class. Yen, Aiman?
FX is increasing with decreasing rate.
Oh, add. We just done it here.
Oh, wait.
Wait.
Increasing at the maximum rate.
Increasing is increasing at the, I will prefer you to say fastest rate, okay? Then the last one for x greater than 9.99. Okay. Can someone describe? Nicholas. Ui.
Yes. For x greater than 9.
Oi. Okay. Louder.
For x greater than 9.99, y equals fx is increasing at a slower rate.
We don't use at the slower rate. Please.
At a
You cannot,
faster rate.
in maths, you cannot use the language that you like. People don't understand that. And if you say at slower rate, also not very true, because is increasing.
It's increasing at the
So try to use maths language.
at the slowest rate.
Hey, is increasing, we don't use at.
Oh,
Okay, is it decreasing at the,
We use with.
oh sorry, decreasing with the slowest, not slowest.
Increasing.
Increasing with the minimum.
You see, I
No.
told you already, when it's become less steep. Yeah, your friends are very, very impatient already.
if decreasing rate.
Yes, thank you. Not I very impatient, your friends. So that is the mathematic language. You cannot sometimes, when come to technical things, you cannot use your own language. Are you clear?
Yes.
Okay, class, you see the graph can look very simple. But when come to the understanding of it, it really need a lot of your effort. Okay, class? Can or not? Okay, thank you, class.
You miss.
Thank you,
Thank you,
Miss.
miss.
Thank you, miss.
Thank you, miss.
Miss.
Thanks, miss.
Thank you,
thank you.
miss.
Yeah.